In today's lecture, we're going to be looking at transformation factors that take into account continuous compounding. We saw in previous lectures that we can consider the compounding period for compounding to be very, very small at times, in fact, to the point of infinitesimality, if that's the right word, so that we're compounding continuously as opposed to periodically. And we developed a formula for that the effective interest under continuous compounding was e to the r minus 1, where r is the nominal interest rate for continuous compounding. And where we have discrete cash flows, we can use that formula to transform those discrete cash flows into future or present worths. However, things could get more complicated than just continuous compounding. We can also have cash flows that are continuous. And in particular, what I want to talk about today is where these cash flows are continuous as well as the compounding be continuous. Here's a problem, for example. We have a widget grinder that's going to be saving us money. It's going to be saving us $10,000 per year, occurring continuously. And the idea here is that if you have a piece of production equipment on the plant floor that's saving money, unlike a bank account that pays interest at the end of a period, that savings occurs right away. It occurs continuously. It occurs every time that the piece of equipment does its activity. That savings will be accumulated by perhaps having less expenses for raw materials or having less expenses for labor on an ongoing basis. And that money that's saved could be invested continuously, perhaps in other plant operations. So when I say savings from a widget grinder of $10,000 per year occurring continuously, that's different from saying it's $10,000 per year occurring at the end of the year. Because each time a little bit of savings made, it can be invested. So, give me some more information here. It'll last 20 years with no scrap value. An effective interest rate of 15% compounded continuously will be paid. How much should be paid for the widget grinder? How much should be paid for the widget grinder? We're looking for a present worth. We're given savings over 20 years that occur per year, but they occur per year differently than they do with periodic payments. Now, you'll notice in your book some formulas for continuous compounding. These ones I've got on the screen here are from page 72 of the text. They're also on the inside cover. And we have a different functional notation for these formulas and a different formula for these formulas. Now, I'm not going to be developing these, and in fact, we don't use continuous compounding very much. But the formulas do exist, and you'll see in the notation we have equivalents to each of the transformation factors that we use for the periodic payments. The difference is that over some of these cash flows, there is a solid bar. For example, a solid bar over the P here, over the F here, and over the A here. What the solid bar refers to is the fact that these cash flows don't occur as they do in periodic payments at the end of the period, but instead they occur continuously throughout the period. In the example problem, we have payments throughout each period of an annuity. So it's the A bar that's appropriate here. The F bar would be if we're looking at a payment that occurred after a certain number of periods, but spread throughout all those periods in the same manner that these savings for the widget grinder are spread through the 1 year period. And the same with the present worth, the bar over it. That means the payment of $10,000 spread over a certain number of years is expressed as a present worth, but it's actually spread over all these future periods. In this problem, we're looking for a present worth. We're given a continuous annuity. So the transformation factor we want is the one at the bottom of this list, going from an annuity to a present worth, an annuity that's continuous. And we have a formula for it. You'll note that the formula is in terms of the nominal interest rate, not the effective rate, and so the notation is also in terms of the nominal rate R rather than the effective rate. In the back of the book, in Appendix C, we also have tables for continuous compounding. And here's a section of the tables for an effective interest rate of 15%, which is the effective interest rate that's given in our problem. You'll note that these tables are in terms of even-numbered effective interest rates and non-integer numbers for the nominal interest rate. So this is a consequence of the fact we tend to express these problems in terms of effective rate, but the formulas themselves are composed of the nominal rate. So we can determine the appropriate number for that factor. Let me formulate the problem here first. What we have is $10,000 per year. We want to find the present worth given a continuous annuity of $10,000 at an effective interest rate of 15%, but since this notation is in terms of R, we can see from this table that the nominal rate that corresponds to that effective rate of 15% is 13.976%. So this is 13.976 over the 20 years. So the expression is fairly straightforward. And solving for that, the value of the expression from tables of the transformation factor from tables is 6.718, gives $67,180. So the answer to the question is that up to $67,180 should be paid for the widget grinder when we're considering only the economic component of the problem. Now, continuous compounding is important because it gives different results than if we use periodic compounding. Let's say we didn't really understand what continuous compounding meant, or we chose not to use it, but we recognize that $10,000 per year, rather than being occurring continuously, as occurring at the end of the year period. So let's say we did it using periodic payments. The expression is very similar, except we're going to be using the regular series present worth factor for the 15%, 20 years. Because the 15% is the effective interest rate for 1 year, of course, is the same as the interest rate for 1 year. And if we work that through, that gives an answer of $62,593. So the importance here is that there's almost a 10% difference between these two numbers. And if, in fact, the widget grinder was $65,000, if we didn't recognize the periodic nature or the continuous nature of these payments, we'd probably say, well, we shouldn't buy this widget grinder because it exceeds its benefits. However, by looking at it appropriate to the nature of the problem with the continuous compounding, it would justify that purchase. So under certain circumstances, this continuing compounding, using continuous compounding and the continuous compounding transformation factors are very appropriate, more appropriate than periodic. Now, to qualify that a little bit, in practice, people don't use continuous compounding very much at all. It's almost never, just because it's more complicated, because the differences, although maybe up to 10%, are often outweighed by other factors in the decision anyhow. But in many ways, it is more accurate, and we should know about it. Thank you.